Okay, so today, as we continue our work with right triangles, we'd like to talk about a couple of special right triangles. You can see our standard. We're going to use special right triangles, two of them, 30-60-90s and 45-45-90s, to solve real-world and mathematical problems. You're going to learn the properties of special right triangles, 45-45-90 and 30-60-90. You're then going to be able to use these properties to solve for the missing sides in these triangles. It's our objective for the day. So certain right triangles have properties that allow us to use shortcuts to determine the side lengths without using the Pythagorean theorem. Let's start with talking about an isosceles right triangle, or a 45-45-90. Remember that if a triangle has congruent angles, then the sides opposite them will also be congruent. So we'll go ahead and label our triangle. Since these angles are both 45, that means the legs are both congruent. So we'll call them X, and then we'll call the hypotenuse C. Now, if we do the Pythagorean theorem, x squared plus x squared, because those are the legs, has to equal c squared. So x squared plus x squared, those are like terms. So that gives us 2x squared equals c squared. And then we take the square root of both sides, and since we don't know the square root of 2, we leave it as a radical form, square root of 2, x square root of 2. So that's the properties of the 45-45-90 that you need to know. Both the legs will be congruent, and the hypotenuse is the square root of 2 times whatever one of the legs is, r. Take a look at this example. Find the value of x. Well, since it's the hypotenuse, it is the square root of 2 times a leg. So the answer, x equals 30 square root of 2. Done. Again, it's a shortcut. You have to recognize that you have the 45-45-90, and then you don't do Pythagorean theorem. You just know that it's this. Now, that's one of the ways we're going to use this. We're going to find a hypotenuse given a leg. The other thing we'll do is we'll find a leg given the hypotenuse, like this example. Again, notice this has to be a 45-45-90 triangle because you have congruent legs in a right triangle. So x is a leg, so we'll take x times the square root of 2 to equal 16, the hypotenuse. We'll then divide both sides by that square root of 2 to isolate x. So we get x equals 16 divided by the square root of 2. However, if you remember from Algebra 1, we cannot have a square root in the denominator, so we have to rationalize it. So we'd multiply both numerator and denominator by the square root of 2, and it comes out and simplifies to 8 square root of 2. The shortcut is this. Just take half the hypotenuse times the square root of 2. Our next special right triangle that we'll use is a 30-60-90 triangle. And to learn about these two properties, we'll start with an equilateral triangle. Remember from earlier work in the first trimester that an equilateral triangle is a triangle that has 3 congruent sides, which means it also has 3 congruent angles, so therefore each one of these angles has to be 60. And we'll drop an altitude from the top vertex. Notice that divides this equilateral triangle into 2 triangles. What would be true about them? Yeah, they're congruent. Why are they congruent? Because of the hypotenuse leg theorem. These two sides become the hypotenuses, and they share this leg. So it's reflexive, so it's HL. That would mean that the sides are the following. 2x, 2x, and these sides down here have to be x and x because they basically, this altitude's bisected this side. So now if we did the Pythagorean theorem, letting b be this other leg, the altitude, maybe I should have used an a instead, x squared plus b squared has to equal 2x quantity squared. So squaring the 2x gives us 4x squared. Getting b alone, because we're trying to solve for b, so we subtracted the x squared over to this side, giving us 3x squared. Then we take the square root, which the square root of x squared would just be x, and the square root of 3 would just be the square root of 3, because we don't know what it is. That gives us the two facts that we need to know. Notice that this leg of this 30, 60, 90, because this is 90, this is 60 still, so this has to be 30. Notice how it's half the hypotenuse, and this is this times the square root of 3. That's our two properties that we need to know about a 30, 60, 90 triangle theorem. The hypotenuse is 2 times the hypotenuse is 2 times the length of the shorter leg. The shorter leg will always be opposite the 30-degree angle because 30 is the smallest angle. The longer leg, opposite 60, is the square root of 3 times the length of the shorter leg. Remember, when we talk opposites, here's the 30-degree angle. The side that doesn't pass through this vertex is its opposite side. In other words, A. Here's 60. Here's the vertex for the 60-degree angle. This is its opposite side. Well, let's look at a couple of examples. Find x and y, or in this case, a and b. The important thing you have to realize is what you're given. You're either given the hypotenuse, the short leg, or the long leg. And in this case, we're given the short leg. The hypotenuse is twice that short leg, so therefore b is 16. The longer leg is the square root of 3 times that short leg, so it's 8 square root of 3. And you leave it in radical form, so you're done. Example 4, now we're asked to find the missing values, and again, we have to realize what we have. So we have the short leg once again. So we double it to find the hypotenuse. And when you take this times 2, you multiply 2 times what's outside the radical. You can't multiply 2 times 3. You don't have to distribute because this is in a radical and this isn't. So this is just 10 square root of 3. The longer leg, we multiply the short leg by the square root of 3. So it's 5 square root of 3 times the square root of 3. When you multiply these radicals together, you multiply the radicands, what's underneath the square root symbol. So the square root of 3 times the square root of 3, well, that would be the square root of 9. But the square root of 9 is just 3. So 5 times 3 is 15, and we have the longer leg. This is the tricky one, where we have to find the short leg and the hypotenuse given the long leg. So first we'll find the short leg, because the long leg is related to the short leg. So we have to take x times the square root of 3 equals 12. And again, we got to do some work with radicals. So we divide both sides by the square root of 3. So therefore, x equals 12 divided by the square root of 3. Now we're going to rationalize it, which means we multiply top and bottom by the square root of 3 because we can't have a square root in the bottom. And hopefully this is going to work out like this one did. Notice that we get the square root of 9, square root of 3 times the square root of 3 here. That's just 3, and then 3 cancels the 12 out, so we get 4 square root of 3. Then the hypotenuse, well, that's easy. We just double that short leg, so it's 8 times the square root of 3. And that is today's lesson on special right triangles, 45, 45, 90, 30, 60, 90.